Today we'll be looking at Lesson 2.6 on ratios and proportions. As you've written down in your notes, a ratio is a comparison of two numbers by division. Basically, it's a fraction, okay? It's in fraction form, but the top, or the numerator of the fraction, is being compared to the bottom, or the denominator of the fraction. A proportion is two ratios that are equal to each other. So we're first going to look at whether these two ratios are equal to each other, and then that will help us determine whether it's a proportion or not. So to determine whether each pair of ratios are equivalent ratios, we would need to cross multiply, okay, which basically means to diagonally multiply. So I would multiply, in this case, 6 times 5, and I'd get 30. And I'm checking to see whether 2 times 10 is going to give me 30, which it does not. It gives me 20. So we would determine, no, these are not going to be equivalent ratios, which is equal ratios, and they are also not going to form a proportion. So if we try the next one, we're going to multiply 1 times 30, which is 30, and 6 times 5, which is also 30. So we see that 30 equals 30 in this case, so we would say, yes, these two ratios are equivalent, or they form a proportion. All right. Next one. Just like I said before, using cross multiplication is the same thing as when they ask you to use cross products. So we're actually doing the same thing as we did in the last example. Okay, so they have given us two sets here of ratios, and we're going to check whether they form a proportion by cross multiplying. So I'm going to do 0.2 times 0.9, which gives me 0.18. And I'm checking whether that is supposed to equal, or that equals 1.8 times 1, which 1.8 times 1 is 1.8. So yes, they have the same numbers, but one is 0.18 and one is 1.8, so they are not the same. So these two ratios would not form a proportion. And then same idea for the next two ratios. So I would multiply 15 times 42, which gives me 630. And I'm checking to see whether that equals 36 times 35, which it does not. It's 1260. So that is also not equal. So those two would not form a proportion. Here, we can again use cross products, which I believe is the best method and the easiest method to solve any proportion. It will work every time. So cross products or cross multiplication just means that I'm multiplying, like I did before, with the numerator of one ratio to the denominator of the other. So I'm going to multiply here r times 40, because I'm solving for r, and that gives me 40r. And then I'm multiplying 25 times 8, which gives me 200. And then, to find r, I would always need to divide here to cancel out the 40. So r would be 5. But the beginning part of solving any proportion, you always want to cross multiply and put one side equal to the other. The next one, you can see here they have x plus 4 times 8. So if I'm going to multiply a group by a number, I'm going to group it together in parentheses. and then on the other side it's going to be equal to 5 times 3, which would be 15. So then I'm trying to solve for x here. I notice that I need to use the distributive property, since I need to distribute the 8 to both the x and the 4. So I would get 8x plus 32. And now I'm solving for x, so this is a two-step equation. I'm going to subtract 32, and I get 15 minus 32, which gives me negative 17. And I have 8x equals negative 17. Then I would divide both sides by 8. I'm running out of room here. And I'd get actually a decimal here. It's going to be a negative number because I did negative 17 divided by 8. So one negative and one positive when I'm dividing gives me a negative. It asks us to round, if necessary, to the nearest hundredth. So I get about negative 2.125. So the nearest hundredth would make that up to negative 2.13. And that would be my answer. Okay, so I kind of messed up here. I'm not quite sure where I stopped the recording and where I started the recording, so I'm going to start way back where we were using the cross products here to determine each pair of ratios. So as I was mentioning in the first example, whenever you're trying to solve or to determine whether the ratios form a proportion, you're always going to cross multiply. So I cross multiplied with the 0.2 times the 0.9 here, and I got 0.18, and then I cross multiplied 1.8 times 1, and I got 1.8, and since neither one of those are equal to each other, that would be a no for forming a proportion. Again, with the next example, I'm doing the same thing, 15 times 42, and that's 630, and then 36 times 35 is 1260, so they are again not equal to each other. So these would not form a proportion. Here we're solving the proportion, so it says if necessary round to the nearest hundredth. So again, if you look at my steps here, for solving I would need to cross multiply as well. So I cross multiplied r times 40 to get 40r equals 200, which is 8 times 25, and then I would solve for r by dividing by 40, and that would give me r equals 5. But for the other one, you notice that you have x plus 4. If it's a grouping of a number and a variable, you could use the distributive property, or you should use the distributive property. So I'm cross multiplying 8 times x plus 4, but notice how I wrote it, 8 and then x plus 4 in parentheses. So I distributed the 8 to both the x and the 4 to get 8x plus 32. On the other side of the equal sign, all I did was do 5 times 3 to give me 15. So I'm solving for x. I have 8x plus 32 equals 15. I would need to subtract by 32 on both sides, and then I would divide by 8. So my answer would give me x equals about negative 2.13, and that's because I had to round to the nearest hundredth, as it had asked me to. So, next example, whenever you're coming up with an answer to a word problem, and it's talking about rate or some sort of rate, you can set up a proportion where you have two ratios that you put equal to each other, but you need to make sure that the ratios have matching numerators and denominators in terms of the labels. So notice that both the numerators of my ratios are minutes, because it says it takes 7 minutes for Isabella to walk around the track twice. So I'm taking the 2 times she walked around the track and the 7 minutes and creating a ratio. 7 minutes over 2 times. Then on the other side, it says how many times so that's why we have x for my denominator. Can she walk around the track in a half hour? And the half hour I turned into minutes, so I have 30 minutes as my numerator. And again, I can cross multiply always, so I have 7 times x, which is 7x, equals 60, and I would divide by 7. So I get about x equals 8.6, and I rounded that to the nearest tenth, but really I would say it makes most sense to just round it to the nearest whole number. I'm not going to round it up to 9. I'm going to round it to 8 because she's not going to walk a partial amount, and saying that she could walk about 9 is a little misleading because she can only walk about 8.6. So I would say the closest or the most realistic answer to that would be to say she could walk about 8 times around the track. Excuse me. Now we have a scale problem. And a scale problem, the reason why we have scale in here is because scale, when you're trying to solve a problem where they're giving you the scale of something, you can use that to set up a ratio. So in this case we have 5 centimeters equals 2 meters. So on a model airplane, 5 centimeters on the airplane for the model equals 2 meters in real life on a real airplane. So I set that up as 5 centimeters over 2 meters. Then it's giving us the model's wingspan, which is 28.5 centimeters. Notice that's my other ratio, and I put centimeters both as my numerators. I'm asked to answer the actual wingspan, which we don't know, so that's going to be x. And I would solve by cross multiplying. I get 5x equals 57, and then I divide by 5 to get x equals 11. Excuse me, 11.4 meters. And that concludes Lesson 2.6.